Welcome to Epic Graph Battles of Algebra! This week in Graph Battles we have Mr. Bigsby versus Mr. Bigsby with a hat. Begin. Alright, what do we got here? How about a quadratic function? Well, that was pretty easy. How about it has a curve? Alright, you want to keep playing the easy ones? Vertical line test passes it. Alright, how about it opens downward? There's something new we learned. Opens downward. Alright, let's get into our vocabulary. I see that it has a y-intercept of 0 and 9. I see that here in the equation, and I also see it right here on the graph. Not too bad. How about the vertex? The vertex is the highest or lowest point. That would be right here, which has a coordinate pair of, let's see, 1 and 12. 1 and 12. Since you gave me the vertex, I can write it in vertex form. Now remember, vertex form is going to be our a value, which I can steal the a value from my equation up here, -3. Then I'm going to have an x minus the x coordinate of my vertex, 1. So x minus 1. Put it all in parentheses and square it. And then add the y value of the vertex. Vertex form. Alright, not bad. How about the zeros? The zeros of this will be -1 and 0. And the other 0 is 1, 2, 3 and 0. And they're also called the x-intercepts. Ha, you can't steal that. I wasn't going to say x-intercepts anyway. That was too easy. Instead, I'm going to give you factored form. Factored form. Since I have the zeros, I can write it in factored form. I start with the same a value, -3, same a value as the other ones, and then I do x, the opposite of your first 0, plus 1, and then in the other parentheses, x, the opposite of your +3, minus 3. There's factored form. Alright, how about the domain? The domain is an interval notation written as -infinity to +infinity. Domain. Alright, since you took the domain, I'll take the range. Range is up and down. This one starts at -infinity. It has no minimum. And it goes up all the way until 12. So the range is -infinity to 12, written in interval notation. Speaking of intervals, let's do interval of increase. What is the interval that this function increases? Uh-oh, the pen is acting up. Interval of increase. Well, I could make the mistake of thinking it's up and down, but it's not. Intervals are always measured on the x. So this function increases until it hits 1. So the interval of increase will be from -infinity until 1. Well, since you gave me the interval of increase, the interval of decrease is always the same number, since now it's going to be from 1 until infinity. It'll be decreasing. So 1 until infinity. Interval of decrease. Stop stealing my easy ones. Alright, it's time to do something hard. Rate of change. Alright, in order to calculate rate of change, I need 2 points. I'm going to choose this 0 here and the vertex. So let's see. What does this thing change over the interval of -1 until +1? That interval from here to here. What does it change? Well, first I take this point here of -1 and 0, and I find the rise, change in y, to this point up here. Well, it's gone up 12. And then I divide it by the change in x. It's gone over 2. The rate of change from this 0 to the vertex is 6, +6, over the interval -1 to +1. You think I can't steal that? I can do the same thing. How about the rate of change from the interval of 1 until 3, until the other 0? What's the rate of change from the vertex to the next 0? Well, what's the change in y from the vertex down to this 0? That would be -12. Change in y is -12. And then change in x is 2 again. So this time I got -12 divided by 2 is -6. The rate of change over the interval of 1 to 3 is -6. Ha! Stole it. Alright, I'm going to use the last 2 points. The y-intercept and the vertex. The rate of change, let's see. The change from the y-intercept up to the vertex was from 9 to 12. So let's see. 9 minus 12 gives me -3. The change in my x over those same 2 points is just 1. It just went over 1. It went from 0 to 1. That's a change of -1. -3 over -1 is 3. The rate of change from the y-intercept to the vertex is 3. What is left? How about the axis of symmetry? We forgot that. Axis of symmetry is always the x of my vertex. Axis of symmetry is x equals, where's my vertex? 1. X equals 1. Always taking the easy ones. Alright, it's time to break out the transformations. This has a vertical translation. Vertical translation of, let's go look at my vertex form. The outside tells me that it's gone up 12. Vertical translation of up 12. Okay, well, it's had a horizontal translation. Horizontal translation of, let's see, the equation in my vertex form had a -1, but I know it's the opposite, so it went to the right one. Right one. My vertex tells me that it did go over 1 up 12. What other transformations have happened? Well, I see a negative in front of my vertex in all of my a values, so I know this is reflected. Reflected because of the negative. I also can see that this parabola is upside down. It reflected. There's got to be another transformation. There's always 4. Oh, the a value is 3. That means that it dilated. Dilation of 3. That makes it narrow. Oh no, we're running out of space. What is left? What haven't I said? It has an absolute maximum. Oh, I said that one already. I'm running out. How about there's a relationship between x and y? That one was so weak. How about it's increasing, then decreasing? The direction of parabola goes up, then down. Ah, why didn't I think of that? Oh no. What's left? Yes, I win! Mr. Bigsby with a hat is the winner! If you see any that we missed, write them in the comments. Well, I'll see you in class.